sketching polynomials, we are looking at cubics. In order to sketch a cubic, you need to identify the up to 3 X-intercepts by using the null factor law. If you haven't factorized first, then you would factorize. This has been factorized for us. So we use the null factor law, let y equals 0 to find our x-intercepts, and we find the y-intercept by letting x equal 0. Once we have the x-intercepts and the y-intercepts, we look at the coefficient of x cubed to see which way our cubic goes, and we sketch it showing those points. So for example, this one here has been factorized for us. So we let y equal 0. To find, of course, our x-intercepts. So therefore, x plus 2 equals 0, or x minus 1 equals 0, or x minus 3 equals 0, x equals negative 2, or x equals 1, or x equals 3. So our x-intercepts are negative 2, 0, 1, 0, and 3, 0. After that, we need to find our y-intercept, and we'll evaluate y for that, and really all that means is you just take these 3 terms, so y equals 2 times negative 1 times negative 3, so y equals 6. So our y-intercept is 0, 6. Once you've got that information, sorry, that pen's getting a little light there. Mark those intercepts. Remember, we are sketching, so it's fine simply to label our axes, mark points that look reasonably realistic. So I need x is negative 2, x is 1, and x is 3, so just as long as it's further out than the 2 was. I'll label these after I've put the cubic in, because otherwise they're going to get in the way. And something that looks reasonably suitable for the y-intercept of 0, 6. Now, we are just sketching with these aspects, and the one thing we do need to know is that our x cubed, x times x times x, is positive, and so our graph points upwards to the right. That means this is a good starting point going upwards from that last intercept. That says, when we sketch what we've got here, that we're going to create a curve that comes down, up through that intercept, up, turns around, and down. Then put these in once the line is out of the way, label your graph, and you have sketched your cubic. Now, working out the turning points, we're not doing. Obviously, that would give us more accuracy if we did that. Another example, which is a negative cubic. If you're feeling confident, please feel free to move at this point and get your work done. So we find our x-intercepts when y equals 0. So negative x equals 0, or x plus 3 equals 0, or x minus 2 is 0. X is 0, or x is negative 3, or x is 2. So our x-intercepts are 0, 0, negative 3, 0, and 2, 0. We find our y-intercept when x equals 0, y equals, well, 0, negative 0 even, times 3, times negative 2. And because we've got 0 times all these things, we have y is 0, so my y-intercept, which we knew anyway, is 0, 0. Draw your axes. We've got point at negative 3, 0, and 2. Now, because this one is a negative coefficient of x cubed, that means our graph comes down to the right. So once you've identified that, continue your curve to go through the other intercepts. Label your graph. So because we're not working out the turning points, it's, label, what do we have? Negative 3, 0, and 2. Because we're not working out the turning points, it's not an accurate representation of the graph. It is a sketch of the graph. Obviously, where these turning points and axes of symmetry end up is something to be dealt with later on. And at the moment, I can't remember if the course goes there, so I'll go find out. But that is sketching cubics.